Hi everyone, I'm Sanu Sagar. I'm a motion designer at Rive. As many of you know, Rive now supports low-level 3D and shaders, which is a major addition that opens a lot of exciting possibilities. Since these features are developer-focused and intentionally low-level, you'll need to create a few scripts to get everything working smoothly. In this tutorial, I'll walk you through exactly how to set things up, explaining the core concepts, and show you how to build the necessary scripts so you can start working with 3D assets and shaders in Rive. Okay, now let's take a look at the key controls we'll need to build in order to make the 3D work inside Rive. So first one is the model importer. Of course, we need file input where we can paste our 3D model and it can load inside the editor. We'd want controls like position, rotation, scale, opacity, maybe some sort of multi-sample anti-aliasing quality control. For lighting controls, we'd need controls like light angle, light height, key color and intensity, fill color and intensity, ambient color and intensity, environment intensity and color, shadow darkness. For materials, we can have base color, roughness, metallic value, ambient occlusion, emissive color and intensity, opacity, different shading modes. So one could be a Gorard shading, two could be a PBR style shading, three could be a sketch and tune shading, etc., etc. And finally, we'll add camera controls, including position, rotation, focal length, clipping planes, etc., etc. Okay, next we'll take all this information and turn it into a prompt. Okay, so what I did was just took my planning docs and pasted into Claude, and it gave me a nice prompt, which I can just copy and paste inside Rive AI. So we'll go ahead and just copy all of this and paste it inside the Rive editor. A few things to keep in mind. You don't need to define every control upfront. You can always add, remove, or modify properties as your needs evolve. Also, don't expect the AI to generate a fully functional script on the first try. Building scripts is often an iterative process that requires some back and forth to refine the logic, fix issues, and get everything working the way you want. Different AI models will produce different results. I primarily use Sonnet 4.6 for most tasks because it's fast, capable, and relatively credit efficient. For more complex debugging, advanced reasoning, or large multi-system workflows, I switch to Opus 4.7 or 4.8. While they consume more credits, they often produce more robust and reliable results for challenging problems. Okay, so finally we are inside Rive. Let's paste the prompt into Rive AI and let it build the scripts for us. Since this prompt defines the overall architecture, let's start with more powerful options like Opus 4.7 or 4.8. Once the foundation is solid, we can switch to lighter models such as Sonnet 4.6. The reason is simple. Architectural mistakes made early can cost far more time than the additional tokens spent on a stronger model. More capable models are generally better at understanding the bigger picture and avoiding costly design dead ends. I'm gonna paste the prompt we just created in here and ask Rive to generate the scripts for us. Okay, so it looks like we have the scripts now, and we'll go ahead and test it using a 3D model. Okay, so the script was not working initially. So I asked the, AI agent. I told the AI agent that I don't see any model, and after a couple of attempts, it was able to figure it out. And let's test it now. So I'm gonna go into the node, and I have all the scripts. So one for the model, one for the model import, one for the material, oops, one for the lighting, and one for camera. So we'll start with the model importer. So as you can see now, there's a 3D cube spinning, and just to let you know, I asked the AI to give me a rotating 3D cube just to debug, the 3D issue I was having. So yeah, you can see there's a cube here. So now let's try to bring in a 3D model. To bring in the 3D model into the project, we'll first need to make sure it's the correct format. Since our script is designed to load GLB files, we'll be importing a GLB model. You can either download it from the web or export any model from Cinema 4D in the GLB format. Okay, so let me show you the model I'll be using. It's a nicely textured satellite model with a decent level of detail, making it perfect for testing and demonstration purposes. Okay, so in order to bring in the 3D model, all you have to do is select the model, drag it into the assets panel, and you will get a pop-up saying import as a blob asset, and you have to select import as blob, and the model should be inside Rive. So we'll give it a few seconds. Okay, now it's loaded. So all you have to do is select the model importer, and you see GLB file input we have here. All you have to do is select the file, copy the name, and just paste it in here. You can do it manually, totally fine. So you do that, and boom, the model is in here. You need to increase the size a bit. Let's see. So yeah, it's there. It's working. Now that we have the 3D model working in Rive, let's review all the properties available in model importer, camera, lighting, and material scripts. We'll start with model importer and go through all the properties one by one. So let's check position. X is working, Y is working, Z is also working. Nice. And you can also reset it like this. You can see rotation is working fine. Perfect. The scale we already tried, it's working. Opacity, perfect. The MSAA stands for multi-sample anti-aliasing. So it controls the aliasing going on in the scene. Right now, the model looks, really bad, and you can see the aliasing. But I think it's because the size is super low, so we need to increase it. Let's say 1920 by 1080. It's a standard full HD size, and now it's looking much better. So the MSAA is supposed to get rid of the aliasing happening on the model, but looks like it's not really affecting it. Yep. So we'll fix it later. Okay, so now let's test the lighting script. So we'll right click and go to node and add lighting. So let's test all the properties. So light angle is working, light height is also working. So as you can see, all the color properties in this lighting script are color code input, but we'd rather ask the AI to change it to a color picker, because that'd be super intuitive. So let's go ahead and do it. Okay, so as you can see, I asked the agent to give me color picker property instead of color code property. and it has replaced it with the color picker. So you can see we have now the key color, the fill color, and the ambient color, and all of these are working totally fine. We also have like key intensity, fill intensity, and ambient intensity. We don't need environment intensity. Maybe it's we can link it to HDRI later, but I don't want it right now. We have shadow darkness. Okay, now let's test the camera. Uh, so camera yaw, camera pitch, camera distance. Oops. Okay. Okay, looks like something is wrong with the camera distance, so we're gonna have to fix it. So just for now, we'll reset it. So I'm gonna have to delete it, I guess. I'll try re-adding the camera. Okay, now we're back. So we won't touch camera distance, and we'll fix it later. Let's change the focal length. Sorry, let's change the camera field of view. Camera near. Okay, so it looks like camera near and camera far is not working. The camera focal length is also not working. Camera orbit speed. First, let's turn on auto spin. Okay, this is working, and orbit speed is working. And last but not least, we'll test the material. So the base color is working. Roughness is also working. It's doing something. Yeah, it's working. The metallic value is not working. AO is working, not the way I want it to, but like it's doing something. And emissive color, let's turn on the intensity. Yeah, it's also working. Cool. Let's try the shading mode. Okay, so completely flat render. Second one, well, this looks more of like a motion vector to me. And then so I think my prompt did not get into the details of the shading modes I wanted, so I'll have to give additional instruction in order to make the shading mode work. Okay, so as we can see, the initial prompt gave us a really strong foundation, and most of the properties are working as expected. However, there are still a few issues to solve. For example, the shading mode aren't working correctly. The camera focal length is also not working, and the model importer isn't importing the UV texture embedded in the 3D file. I could spend a significant amount of time fixing these issues and refining the script until everything works exactly the way I want. However, that would require a lot of iteration and consume a large amount of tokens. So, in the second part of this tutorial, I'll share the 3D scripts which I built earlier and are in much polished state. I'll walk you through how it works, explain the different components, and I'll share the file so you can use it directly without having to rebuild everything from scratch. So I'll see you in the next part. Thanks for watching.